This video is about the derivation of resistance and power in a DC circuit based on a point form of Ohm's law. So the point form of Ohm's law which was derived was that the current density is equal to conductivity into electrical field intensity, and the unit is of the current density is ampere per meter square, and electrical field intensity is given by Newton per Coulomb, and sigma is equal to the conductivity, and the inverse of the conductivity is known as the resistivity. So essentially, conductivity is how easily the electrons can flow in a conductor, and the resistivity is the opposition to the flow of the electrons, both with some function of the effect, some function which depicts the effect of temperature. But if you consider a simple case of a conductor, which is a wire, which you can assume as a wire having cross-sectional area of A. So now this wire is connected to a DC battery. So when this is connected to a DC battery with the positive and the negative side, an electrical field will be generated which will be in this direction, and the electrons inside will have a motion which will be in this direction. So, and if you say that the length of the conductor is L and the potential is V, so now our task is to derive the equation of resistance. So this is from the point form of the Ohm's law. So this is the point form of Ohm's law, and the Ohm's law otherwise could be written from the triangle form, and it could be said that V is equal to IR in any circuit or any resistive circuit. So considering the same case, now you can say that the electrical field intensity E is equal to V divided by L. This is based on the equation of potential which we have derived. So based on the equation of potential, it can be said that E is equal to V by L, and J is equal to I divided by S, that is equal to the surface area, and so this is the second equation, and this is the third equation, and this was our first equation. So based on the first equation, it can be again said that I by S is equal to sigma into V by L. So I can say that V by I for my circuit is equal to 1 upon or L divided by sigma into S. So this is again equal to V by I equal to rho L by A, because 1 upon sigma is equal to the resistivity. So V by I is equal to what is known as my resistance, and if I write that here, it is equal to rho L by A. So, and the unit of the resistance will be in ohms. So this is how I am deriving the resistance of the circuit, and it is directly proportional to the resistivity, it is directly proportional to the length, and it is inversely proportional to the area. The area here is the surface area which I have taken. So the area if for a square will be in meter square, for a rectangle or for a cylindrical surface it can be found out from the respective formulas. And our next task is to find out what is known as, so we found out that what we found out so far is a point form of Ohm's law, which is J is equal to sigma E. This was the first equation, and the next equation was R is equal to rho L by A, which is equal to the equation of the resistance. And now again there is a third equation. This is a point form of Ohm's law. So again there is a third equation which is known as Joules law in electrical circuits. So to derive the Joules law, which is the equation of power in electrical circuits. So the unit of power is equal to watts. Also it can be written in terms of joules, but it is so power can be given by the equation of force into velocity. So if you are giving the equation of so what is my force? So I can say that my force is equal to so based on the Coulomb's law, which says that electrical field intensity is equal to force divided by charge, I can say that force is equal to Q into E. So if I'm considering the case of a conductor, so the conductor will be, the charge will be present in form of a volume. So the volume charge density will be rho v, and if I'm considering an infinitely small area of dv, then this will be equal to what is known as my dq. So I can say that my force is equal to integration of rho v dv into E, that is the electrical field density from here. And the next thing is, what is my velocity? My velocity is my drift velocity, so that it will be the multiplied here. So rho v into u is equal to what is my current charge density, J. So this equation will become F is equal to integration V E dot J dV. And this is not the equation of force, it is the equation of power. So my work done, this is known as my Joules law. And what is the equation of power? So the WP will be equal to dP by dV. So this will be equal to the derivation of this. So what I will get is E dot J, and this is a work done. And when I'm doing this, the next step is, substituting the value of the J from the equation 1. So if I'm saying this was my equation 3 which I got, and this was my equation 4 which I'm getting now, then my WP will be equal to E into sigma E, which is equal to sigma E square. So this is my fifth equation which I have got. So WP is equal to sigma E square. This is my fifth equation which I have derived, and this equation which I can write here, it is known as the equation of power density or power per meter cube. But to derive the Coulomb Joules law, this is what is my Joules law, and if I'm simplifying my Joules law, it's possible to get it in form which we are familiar with. We can say that my dV is equal to my dl into ds, that is my for my volume. So if I am integrating P is equal to integration V E dot dl into J dot ds. So if I'm writing it here, so my P is equal to, what is my E dot dl when I'm integrating it? So I will do a line integral, then I will do a surface integral. So what is my E dot dl is my voltage or potential, and J dot ds is what is my current. So this is based on what we had derived previously in the series of lectures. So based on knowing my potential and based on knowing my, like, J is equal to I by A, that is J into A is your I, and your field into your length is what is giving you a potential. So what you have got here is P is equal to Vi. If you are substituting the value of V here as IR, you can get in form of resistance as I square R. So this is valid for resistive circuits for DC and AC, and it's possible to compute the active power using this. And if you are considering the power factor in case of AC circuits, the equation is the same, and this is known as what is my P is equal to Vi, or P is equal to I square R, is known as what is known as my Joules law for electrical circuits, which we have derived using this derivation. So that's all. If you like this video, please do subscribe. Also do watch other videos in the series to learn more about the electromagnetics, electric fields and electrical engineering, etc.